This right here is a basic transformer, very similar to the one we made in class. How it works is we run power through what's called the primary coil. This will always generate a magnetic field. If it's alternating current, if it's direct current, this makes a magnetic field. However, the contrapositive is not true. A steady magnetic field will never induce a current. So when the magnetic field is changing, that you get a current on the other side, which is why transformers only work with alternating currents. So what we do is we pass AC through this wire, it generates a constantly changing magnetic field, and then that induces a current on the other side, and then AC current is passed through. If these have the same number of turns, it's equal current on both sides. If this has double the turns of the secondary, then our current output doubles. If it has half, current output halves, and on and on. It's a very one-to-one relationship. Another thing about transformers is we wrap the coils around a ferrous material, not because it's strictly necessary for the magnetic field to be induced, but just because it increases the strength of a magnetic field and reduces energy loss. This happens because all electrons have a magnetic moment because of the spin. Why is this true? I really could not tell you. That is above the pay grade of an introductory physics student. But we know this is true. And we also know that a lot of atoms are going to have a couple upspins and a couple downspins because the shells are either very lightly filled or almost completely filled. However, right in the middle of the periodic table, we have our ferrous materials, which are all metals, which have 4 upspin electrons in the valence shell. This allows the atom to have a magnetic moment. Then when we put a bunch together, we get what's called magnetic domains. Each one of these domains has a magnetic field. However, they're all counteracting each other, and we get about a net zero magnetic field. However, if we run a B field over this ferrous material, they're all going to align with the B field, generating a net magnetic moment, increasing the strength of magnetic field of the transformer, which is why we use them. It just makes them more efficient. The other thing you do when making a transformer is instead of just having one big block of iron, you have to cut it into a bunch of tiny little sheets and laminate them together to prevent losing power to what's called eddy currents. Eddy currents is just when energy over a sheet of metal induces a swirling electric field inside the metal, which causes energy loss. However, the formula that determines eddy currents is by volume, not by surface area, meaning you can significantly reduce the impact on the system if you just get a bunch of small sheets with very little volume and stack them together.